The very short wavelength of the produced synchrotron light enables studying atomic and molecular structure of the material.
We can look at ancient artifacts, we can look at ancient archaeological treasures.
The Middle East is a region of rich history.
We are sitting, after all, into the cradle of civilization.
A source of pride to all the scientists in the region.
SESAME was officially opened in Amman, Jordan on 16th of May 2017.
The aim for establishing SESAME is to reverse the brain drain for scientists from the Middle East, in addition to establishing science diplomacy and be exemplary model for Science for Peace project in the Middle East. SESAME is governed by the SESAME Council. The SESAME Council also includes organizations such as UNESCO, European Union, also SESAME.
SESAME is a synchrotron radiation source. By this, I mean we are producing light which is then used for measuring atoms in matter. And in this way, we have a probe to understand how matter behaves at the atomic, molecular, and micro level.
Currently, we have 5 beamlines which are operational.
SESAME is fully powered by renewable energy. Thanks to the European Union for granting about $7 million to construct this solar power plant with a capacity of 7.48 megawatt. By using this solar power plant, SESAME becomes sustainable.
SESAME actually has enabled and opened the window for scientists in the region to really do state-of-the-art forefront research and publish the results in the most prestigious scientific journals of the world.
SESAME opened the door for many women scientists in the region. Instead of going to the West, they can come here. And this made it so much easy for them to keep their traditions, to keep their family commitments, and in the same time to proceed with a high-quality scientific domain.
By opening the doors of such advanced scientific research, it reverses the brain drain from the region. SESAME also represents a hub of knowledge and communication and training center for the students and the scientists.
There are almost 50 synchrotron facilities all over the world, and SESAME is the only one for us in the region.
We are using SESAME to do contemporary research in order to address some of the challenges that face the region, namely climate change, water, energy, food, and environment.
We scanned bones and teeth from a population from Cyprus around 3,500 years old. We also scanned some plants with very high resolution, looking at fiber plants with 650 nanometers in resolution.
While performing research at SESAME, the users opt to stay at the guest house, which is located in the SESAME campus. The guest house consists of 48 bedrooms. SESAME supports the researchers coming to Jordan to do research at SESAME with a round-flight ticket and also transportation from and to the airport and stay at the guest house.
We have at the moment 5 beamlines working. A 6th one is in this moment under construction. It will sit exactly where I am standing now. This beamline is extremely important because it is the very first beamline built in the Middle East.
The major upgrade for the machine in the future will be replacing of the existing low energy injector with a high energy injector to keep the electron beam current constant in the storage ring. It will enable injection of different filling patterns as requested by some type of experiments.
SESAME is a cave of treasure in the Middle East, and it is open for all scientists from its members and overall the world.
They are able to really fine-tune some of their expertise and also to fulfill some of the research projects that they want to do using some of the very state-of-the-art beamlines that SESAME is providing. SESAME actually grew to become more of an international research center, wide open to helping other regions in the world to build such facilities.
SESAME has been the first synchrotron to sign a memorandum of understanding with the African Light Source Foundation, and we are working together to bring up this idea of having in the future a machine built in Africa, and for the moment to interact with them by training users and scientists to the use of these techniques.
I see the future of SESAME as a center of excellence in the scientific research and as a major hub of knowledge, collaboration and communication.
We are growing by the day, whether in enhancing the machine capabilities and continuing the build-up of new beamlines on SESAME. We will build 3 new beamlines in the future, and we will continue adding more beamlines so that we can expand on the scientific excellence that we have already established robustly in this part of the world.